Hey guys, welcome to Thursday, April 23rd. Today we're going to graph cube roots, which are very similar to what we did on Wednesday, the graphing of square roots. Today our graph is going to look like this. This is what the basic parent function looks like. So it's kind of like a squatty S. Okay, so it's an S that's been kind of shortened. Okay, so you're going to see quite a bit of the same material that we looked at yesterday. Today we're going to do the cube root part of this. Okay, and so we're going to graph the parent function like we did yesterday. So again, when you don't know how to graph something, you use a T-chart. And so in this T-chart, we have the perfect cubes. Yesterday we had perfect squares. Today we have perfect cubes. Now one thing you may notice is today is that we have negative values. Yesterday we did not have negative values because when you take the square root of a negative value, you get a complex number, which doesn't really exist. You can take the cube root of a negative value though, because of the number times itself. So there's three of the same number, so you can get a negative that way. So to fill in the y values for the cube roots, for the parent function of the cube roots, the cube root of -8 is -2. Cube root of -1 is -1. Cube root of 0 is 0. Cube root of 1 is 1. And the cube root of 8 is 2. So again, that's the parent function. You'll see us use that quite a bit as we progress through the graphing of the cube roots. So let's graph its parent function. We'll start here at -8, -2. So let's see, -8, -2. Then we'll go to -1, -1. 0, 0. 1, 1. And 8, 2. And so all that gets connected. We have arrows on both ends. So as we come down to domain and range, okay, let me put this on here. That is the parent graph. That is the basic cube root. So as we do domain and range, remember domain is left to right. Far left is negative infinity. Far right is positive infinity. Parentheses on both. Range, bottom of the graph to the top of the graph. So bottom of the graph is also this arrow. Remember, this continues to go down forever. So we have negative infinity again. This is the top of the graph. It goes up forever. So it's positive infinity. And remember that if you have negative to positive infinity, you can also use the all real number symbol. Now, something that's a little bit different here for cube roots is that this will always be the domain and the range for cube root functions. No matter if it's a negative function, if it's got a horizontal shift, a vertical shift, no matter what. These are always going to be your domains and ranges for your cube root functions. Just cube root though, not square root, cube root. All right, so that's our parent graph. These are the transformations from yesterday. The stuff is exactly the same for every graph that we do, whether it's cube root or square root. A reflects. It also is a vertical stretch, vertical shrink. H is the horizontal shift. Has an inverse relationship. So if H is positive, it goes left. If H is negative, it goes right. K is the vertical shift. Has a direct relationship. So positive is up, negative is down. So this is exactly the same as we saw yesterday with square roots. So again, this is just parent function. So yesterday we did square roots. So today we just changed this to a cube root and everything stays the same. Horizontal shift is still underneath the radical. has the negative in front of it, which says change the sign. That's the inverse relationship. K is outside the function. It's going to be the vertical shift. So this, again, exactly the same as it was yesterday. So just to talk about some transformations of cube root functions as we get back into the graphs today. So we'll look at the same things we saw yesterday. Now, the negative told us the x-axis reflection. Well, neither one of these graphs have a negative, so we won't have any x-axis reflections. Underneath the radical, we have a -1, a +1. So these are our horizontal shifts. So for number 3, this is going to go right 1 unit. For number 4, this is going to go left 1 unit. Remember, a couple of slides back here, the horizontal shift has an inverse relationship. So when the number is positive, it actually flips, goes the other direction, so it goes left. So positive means left here, negative means right here. All right, so do we have any vertical shifts? Yes, we do. We have a vertical shift right here. So the vertical shift has a direct relationship. So since this is a -2, we'll be going down 2 units. And number 4 does not have a number outside the radical, so therefore it doesn't have a vertical shift. Which brings us to the half that's in front of it. So this 5, because it was a number bigger than 1, is a stretch. This half is a number smaller than 1, between 0 and 1, so therefore it has a vertical shrink of 1/2, which is going to act as a multiplier as we get into our t-charts. But you guys probably took care of this in last night's homework from problems 1 through 4, where you're describing the transformations. All right, so just to reiterate the parent function chart for the cube roots, we're going to start with -8, -2, I'm sorry, that's a 1, -1, 0, +1, +8. And the cube roots of those are -2, -1, 0, 1, and 2. So again, we're going to start with our shifts. So these graphs don't have any shifts, they're the parent functions. We're going to start with our shifts, then we're going to graph the parent points from the new vertex. So we'll use these as left 8, down 2, left 1, down 1. That 0, 0 is going to be the vertex, the new vertex. Right 1, up 1, right 8, up 2. Okay, so again, very similar what we saw yesterday with square roots. So let's get into some actual cube roots, see how these go. So let's talk about the 4 in this problem. That 4 is a left 4 unit shift. So from the origin, move your point left 4 units, 1, 2, 3, 4. And as we did yesterday, I'll call this our new vertex. We'll put a little t-chart in here. Those are the perfect cubes that actually fit on the graph. The next perfect cube is a 27, so there's no way we'll ever graph a 27 on here. Cube root of these are -2, 1, -1, 0, 1, and 2. So this green point, that's the new vertex. That one's already graphed. So now we're going to go left 8, down 2 from the new vertex. 1, 2, 3, 4, 5, 6. You have to do your best to estimate. 7, 8, down 2. So it's going to be approximately right there, just a little bit off of the graph. Then we'll go left 1, down 1. left 1, down 1. Put this right there. This is the vertex that's already graphed. So we're to 1, 1, which is right 1, up 1. So from the new vertex, right 1, up 1. And finally, our last point will be right 8, up 2. So from the new vertex, count to the right 8. 1, 2, 3, 4, 5, 6, 7, 8. Go up 2 units. You can see the shape of the cube root graph take effect. Okay, so let's get to domain and range. Let's see if I can find that. Domain and range always have negative to positive infinity. You can use the all real number symbol there to signify or state your domain and range. So our domain, all real numbers, range, all real numbers also. So that's a basic cube root graph where you just had one transformation. So let's take a look at another one that has some different transformations in it. All right, so we have negative 2, cube root of x. So you'll notice that this graph, maybe you do, maybe you don't, there's no horizontal and there's no vertical shift. So that means that our vertex did not move. Our vertex is at the origin. Create a t-chart. And now we have a negative 2. Okay? So, much like yesterday, this acts as a multiplier to y. So all of these get multiplied by negative 2. The negative is an x-axis reflection. The 2 is a stretch. So this graph is going to flip over and then it's going to get taller. So it's going to go up a little bit more and down a little bit more. If you want to, you go ahead and fill in your domain and range because it's cubic and it won't ever change. So now, let's see, we multiply negative 2, negative 1, 0, 1, and 2 by negative 2. So this becomes a 4. This is a 2. This stays 0. This is negative 2. This is negative 4. So we have new y values after we've multiplied by the a value, negative 2. So this negative 2 multiplies to the y values. So we get negative, that's a positive 4. Let's get rid of that. That's a positive 4. That's green. And then we have negative 2 and negative 4 down the bottom. So new points. Left 8, we're going up 4. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. So usually that in the parent function the graph goes down. But this has a negative a value, so the graph reflects over the x-axis. Negative 1, it means left 1. We're going to go up 2. Left 1, up 2. So that's a little bit taller from what we're used to seeing. 0, 0 is the vertex. So we're going to go right 1, down 2, right 1, down 2. And then we're going to go right 8, down 4. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. So it's a little bit taller of a graph, and it's changed directions because of the negative in front of the 2. So this had an x-axis reflection to it. So a lot of similarities to yesterday. We just basically have a different chart of numbers. that we're working with. One more, last one. We got a lot going on this though. So we've got -3 underneath. That means right 3 units. Got -2 off to the side. That means down 2 units. So we have a new vertex at 3, -2. All right. Excuse me. Let's come up with a T-chart real quick. Give myself a little bit more room on this right-hand side. I've been squeezing that in on you. Okay, parent function. These are all perfect cubes. These are their cube roots. This time, we have a half in front of the graph. And so we multiply to the y values. So these values are going to get multiplied by a half. So now, instead, like the previous graph, the graph got bigger. This graph is going to get shorter or smaller, or tighter. It's going to be real narrow. So we'll multiply these by half. So -2 times a half is -1. -1 times a half is -half. 0 times a half is still 0. 1 times a half is half. And 2 times a half is 1. So those green values are now our new y values. So right here, that's what we're going to graph. All right, so that is left 8, down 1. So 1, 2, 3, 4, 5, 6, 7, 8, down 1. Left 1, down half. So this isn't going to look like much. It's going to be real tight. So it's going to be halfway in between the two horizontal lines there. 0, 0, that's the new vertex. We're going to go right 1, up a half. So right 1, up half. So again, pretty small dot. In order for me to get it in there, I can't make it very big with this pen. And the last one, right 8, up 1 from the vertex, from the new vertex. 1, 2, 3, 4, 5, 6, 7, and off the grid, up 1. So this graph, real tight, real small. Okay, that's cube root. Finish off with our domain and our range, and that's it. So it should have taken a little bit longer yesterday because I kind of had to explain all the transformations. But that's how we graph cube roots, very similar to how we graphed square roots. So basically, for homework, it's the same graphing square roots worksheet, except it's really more like just roots, okay? So it's got cube roots and square roots on it. So 5 through 8, 14 through 16, 18, 19, those are all your cube roots. So it's the same worksheet you guys worked on Wednesday. You're just going to have to finish it up. Okay? Look forward to hearing from you. Hope you guys are doing well. We'll talk soon.